We have the following differential equation. We have phi div dx equals cos squared x. Now, there's a little trick that you might not all be quite aware of. Okay, so when you go to your tables, so in general, we're just going to move this around. So we're going to have phi div equals cos squared x dx. We're going to integrate from v and then x, and then we know when v is 1 when x is 0. Now, but we don't integrate products. It's basically cos x multiplied by cos x, and we don't do that. Okay, so here's what I suggest you do instead. You go back to your tables and you look up this here. Okay, cos 2a equals cos squared a minus sin squared a. Now, we also know that cos squared a plus sin squared a equals 1. This implies that sin squared a equals 1 minus cos squared a. So we lop this in here, so we get cos squared a minus bracket minus 1 minus cos squared a. So now we're going to get cos 2a is the same thing as 2 cos squared a minus 1. Next we can transfer it over, so we get cos 2a take away 1 is actually the same thing as cos squared a. Sorry, 2 cos squared a, then half it, so it's going to be a half cos 2a minus 1 equals cos squared a. And then we can substitute this in as simply a half cos 2a minus a half equals cos squared a. So just change them to x's, so it's going to be a half cos 2x minus a half. So it's going to be a half cos 2x minus a half dx, and we can integrate that because it's a much simpler integration than the other one we were expecting. So phi on 1 phi div. So we should be able to get this out. Now integrate phi, you get phi squared over 2 from phi to 1. Integrate a half, just go straight down. Now when you integrate cos 2x, you're going to get sin 2x. But you also, I believe you also got to take into consideration the extra half. Oh, sorry, you're going to multiply it by 2. So there's going to be a 2 at the top as well. Sin 2x, it's actually sin 2x, but you got to put another 2 over. So when you integrate cos 2x, it's sin 2x over 2. Then when you integrate minus a half, you get minus a half x. Okay, this half belongs to the cos 2x, so it's actually we'll just do a bit longer here. It's actually sin 2x over 4 minus a half x from x to 0. And this one over here is phi squared over 2 from phi to 1. Okay, let's throw in our numbers now. So we're going to get phi squared over 2 minus 1 squared over 2, which is minus a half. And then we'll put this in, sin 0 is 0, so it's just going to be the same thing, sin 2x over 4 minus a half x. Now I'm going to do to both sides is I'm going to multiply them by, I'm going to get them common denominator of 4, I believe. So what are we going to do here? Okay, so what's going to happen is I'm going to give them common denominator of 4. So that's going to be 2 phi squared minus 2 equals sin 2x and then minus 2x. Going to bring the 2 out the other side, so it's going to be 2 phi squared equals sin 2x minus 2x plus 2. And then phi squared equals sin 2x over 2 minus x plus 1. Square root both sides, and what we get is sin 2x over 2 minus x plus 1. Was the marking scheme correct? I got a minus x, where they got a plus x. Interesting, that. Ah, sorry, my bad. When I transferred the -1 over, it's a +1. So it's plus a half. So the market scheme was correct as it turns out. So that's a plus. Just be careful about stuff like that. Plus, plus. And then that's a +2x, a +2x, plus x, and a plus x. And now both answers are the same. All right, and we're done.